Right, then we get to net force calculations. Now, net force calculations are based on the idea that net force is simply the single force which has the same effect as the original forces acting together. Right, so the equation that we use here, F net is equal to sigma F. Now sigma F or sigma just represents sum. So it just means the sum of the forces. These three dots here mean that it will continue for as many forces as are acting on the object. Now, one of the important things about this is that we need to give positive or negative signs depending on the direction in which they're acting. So the general way that we do this is to basically assign Cartesian plane coordinates. So it's going to the right, it's positive, up we say it's positive, left negative, and down is negative. Right, so if we look at our first example here, we can see that we have 1 Newton acting to the right, as well as a 2 Newton force acting to the right. So once again, we give these signs, and so this would be positive to the right, positive to the left. And so when we add them up, we'll substitute them both as positive 1 plus positive 2, which means that with these two forces acting together, we get the same effect as a single 3 Newton force. Now, because forces are vectors, we need to say what direction it's acting. So we've defined positive as acting to the right. Therefore, this 3 Newton force is then acting 3 newtons to the right. Okay, now we've got two different forces acting in different directions. So our 2 Newton force is acting to the left. Let's see that over there. And because it's acting to the left, we're now going to define it as a negative force, where the 3 Newton acting to the right is positive. So right is positive. Okay, so when we substitute them in, what we see there, as we're taking right as positive, as mentioned, so take right as positive, we put F net, and this is the same as saying just F1 plus F2, and so that gives us that negative 2 force, and that negative 2 there is substituted then as a negative 2. The positive 3 force is substituted as a positive 3. And so we add the two together. Negative 2 plus 3 means that we're going to get a positive 1. And that positive 1 then is to the right. Here we've got an interesting one. So the man is trying to pick up a box that weighs 100 kilograms. So because the box weighs, 100 newtons, sorry. Box weighs 100 newtons, he is only able to apply a 80 Newton force up, and the box has 100 newtons down. So, according to our Cartesian plane ideas, we're going to define this as positive 80 newtons, and putting down is negative 100. So if we add these two up, that's going to be F, let's call it F up, and F down, forces up and down. And so we substitute them then, that positive 80 gets substituted in as a positive 80. Because the 100 Newton is acting down, we substitute it as negative 100. Sum the two up, and we get negative 20 newtons. So that negative there, because it is negative, it tells us that it is acting downwards. Okay, let's look at some examples here. I'll just do one or two. So let's take this one now. So we've got 4 newtons acting upwards, and 3 newtons and a 1 newton both acting down. So we assign our signs. So positive 4 up, negative 3 down, negative 1 newton down. So we're going to write it out as F net is equal to force 1 plus force 2 plus force 3. So let's label what each of these are going to be. I'm going to call the 4 Newton up force 1, the 3 Newton down force 2, and the 1 Newton down force 3. And we're just going to substitute them in as such. So F net then is going to be 4 newtons plus minus 3 newtons plus minus 1 newton. So 4 minus 3 is 1, minus 1 is 0 newtons. So that means that all these forces here are balanced, and the object is either going to move at constant velocity or stay stationary or standing still. Okay, so let's look at one that isn't going to give us a 0 Newton net force. Once again, we've got 2 going up, so positive, positive. Let's name them F1, F2, F3, and this is going to be a negative force. Right, so write out our equation. Always write out the equation. F1 plus F2 plus F3. And so that is going to be F1, 5 newtons, plus F2, 2 newtons, plus F3, which is minus 4 because it's acting down. So that's going to give us 7 minus 4 is a net force of 3 newtons. Now, because of that, we're then going to say 3 newtons not downwards, upwards, which makes sense because we have defined positive as up, and the answer here is a positive value, so 3 newtons up. Okay, let's do one more just to really solidify this. Okay, so now we've got F1, F2, and F3. Now we need to assign the signs. So the 50 Newton is acting to the right, so we can call that a positive force. The 7 Newton is acting to the left, and so it will become a negative force. And the 2 Newton is also acting to the left, so also a negative. Write out sum, force 1 plus force 2 plus force 3, and so that then is going to be 15 plus minus 7 plus minus 2. Right, so that gives us minus 9 minus 15 is going to be plus 6 newtons. Because of that plus 6, that tells us that it's going to the right, therefore 6 newtons to the right. And so because the forces are not balanced, this object would accelerate, and the direction it will accelerate then is to the right.